I would be delighted if we found life elsewhere, because I feel it would take some of the pressure off. Because my fear, the thing that keeps me awake at night is that life is extremely rare in the universe, and complex life is so rare that we might be the only planet in the Milky Way galaxy where complex life exists currently. So that's a guess, it's a possibility. I cannot claim this, I'm not saying it definitively because we don't know. So if that's the case, then it means if we this up, there might be nowhere else. So my response, if a flying saucer descended now over Broadcasting House here in London, would be one of relief. Be like, thank God that it's not only down to us now, because, you know, we're not making a very good job of it. The honest answer is, personally, I wouldn't go anywhere. I'd stay on Earth because it's all really horrible. So surface of Mars, you could stand there, you'd be okay. Mercury, you wouldn't. Venus, you definitely wouldn't. It's 450 degrees Celsius or so. Sulfuric acid rain. And actually one of the experiments we do in the series demonstrates, it's a chemistry experiment again, demonstrates what would happen to you if you skydived through the clouds of Venus. If we remove the problems away, I'd like to stand on the surface of Neptune's moon Triton. But it's this kind of frozen place with strange eruptions from the surface that kind of rise up into space but then go flat because of this tenuous atmosphere that the place has. So it's just, I would love to stand there and look out onto, with Neptune rising in the sky over this frozen surface. I'd love to do that. But I'd put a big coat on and and come back quickly. I'm going to Triton, I need to get big coat. The great thing about this series, Solar System, is it's all based on new discoveries, new ideas, new data. So I learned a lot in making the series. I mean, we have discoveries, images that were taken in 2023. So it's all during filming. Something like, I can't remember the number, 40-something spacecraft currently active in the solar system. On the surface of Mars and actually out beyond the orbit of Pluto. And the idea of this series was to use the most up-to-date data, which is a great idea until you have to film the series because you're sat on a volcano, having been delivered there by helicopter. That's a cliche, but it's what people expect of me. And someone rings up from London and says, we've got a new, that thing you were going to say is not right because a paper got published yesterday. Northern Alaska, the Denali Glacier, very difficult to get to and tremendously beautiful. And we flew in, which is the only way you can get there, and flew in and landed in this old converted aircraft, a single-engined aircraft that they convert with a big engine on the front and skis on it. And this incredible pilot who has spent her life basically flying around in Alaska. She said, we're going to go over this ridge. And I was with her in the cockpit, and then the film crew are behind in this. And it's like Indiana Jones, and the plane goes, wow, like that, and dropped. And I turn around, and Julius, the director of photography, is back there. And I saw him, and the camera's floating, and he's going, like that, and the camera's doing that. And then he caught, because everything went weightless, and then he caught it again. One of the things that I didn't know, one of the most surprising things that we talk about in the series, there's this possibility that the mountains of Venus are coated in essentially metallic snow, which is just a beautiful idea. So it shows you how the laws of chemistry that we see and experience and investigate here on Earth, they're universal, but you put them in different conditions and you get very different outcomes. There are conditions out in the solar system that we can't recreate even on laboratories here on Earth. Extremes of not only strange chemical composition but pressure and temperature that are very difficult or impossible to create here. So you can use the solar system just as a chemistry set, and there's a real sense of that throughout the series. probably in the atmospheres of gas giants. There's a form of ice that we think forms deep in the atmosphere of Uranus, the planet. Or by the way, there's always a debate about, should we say Uranus, like the Americans, or Uranus? And then everyone else laughs because it sounds like anus. It's an electrically conductive form of ice that we think plays a role in generating the aurora that we see, like the northern and southern lights. So it's so extreme, the conditions that you need to produce this particular form of ice deep in the atmospheres of these gas giants. You get really exotic forms of matter because of the temperatures and pressures that you find there. The long shot would be the existence of life beyond Earth. We are looking actively for evidence that life existed on Mars, for example. And it's not beyond the realms of possibility, but it's aimed at bringing samples back from the surface of Mars, and that will be definitive then. The other target at the moment, we have two missions, one in flight on the way to Europa called JUICE, the Jupiter Icy Moons Explorer. It's a European mission. And then the Europa Clipper mission, those missions are taking, I think, 6-7 years or so to Europa. And Europa is one of the prime candidates for a habitable world. So it's possible just that within 10 years we may see hints that that world is inhabited, which would be quite remarkable. I'm just going to say yes to piss a load of my astronomy colleagues off. There are a lot of worlds out there that are similar to Pluto. So it's one of many worlds out there in the Kuiper Belt. It's a historic accident that the first Kuiper Belt object we really became aware of was Pluto, and we kind of called it a planet, and so it's one of the planets. I don't care, because the thing about Pluto is it's beautiful. It's a beautiful, fascinating world, potentially an active world. It's geologically active. And so it is possible there's liquid water below the surface of Pluto. Therefore, it's possible it may be a habitat for life, and nobody would have imagined that. And it's got mountains of ice floating on glaciers of nitrogen. I genuinely don't care what we call it. It's a fascinating and beautiful world. But I do think it's funny that people have arguments about it. It's a really important part of the series that the laws of nature that operate here on Earth, of course, they are universal laws. So the same laws of nature that govern how an egg rotates, for example, they are the laws that govern how a moon of Saturn rotates. And so we used an egg, a raw egg and a hard-boiled egg, to demonstrate some of the measurements that have been made to infer there's an ocean below the surface of a moon called Enceladus orbiting around Saturn. I did theoretical physics primarily because everything I tried to do as an experiment just broke. And so you'll see that it's the first experiment, I think, that we do in the first program. And I pick this egg up and drop it and it just breaks. And so we left that in, because that is my level of competence. And there is a serious point, because they do illustrate deep physical principles. And the fact that you can illustrate physical principles and study them with just the everyday things that you find lying around is a wonderful thing. It could have rings if something hits the moon, I suppose. So it would have to be a big thing. And there's no evidence of anything big coming. I'm going to start one of those conspiracies. As far as I've been told. We do in the series talk about Mars and Mars's moons, Phobos and Deimos. The way that Phobos interacts with Mars gravitationally means it's moving in, and it will turn into a ring, we think. And that's probably the origin of Saturn's rings as well, a moon drifting in too close to the planet. But our moon is going further away, and I have no knowledge of anything. Don't put that.